Hello everyone. Welcome to MH Math Academy's KCET Crash Course 2025. In this lecture, we are going to start with our first chapter, that is sets. If you remember, this was the very first chapter that you had taken up when you entered your PUC, and it is a very easy chapter, and you can expect either one question or no questions for KCET from this particular chapter. Uh, Even the questions that they are going to ask are going to be very easy and very direct questions which are totally based on NCERT. Of course, no out of the box questions till now from this particular chapter. So with this we shall start with the basic revision of whatever we have learned in the chapter sets in this lecture, and in the next lecture we shall take up a few previous year questions and a few more questions from the chapter sets. Okay, so without any further delay, let me first start with the definition of a set. What is a set? What was the definition of set that we had given in the first year PUC? It is the well-defined collection of objects. So, what do you mean by the well-defined collection of objects? It is the well-defined collection of objects. What do you mean by the well-defined collection of objects? If I say the set of all good writers of India, for a few of you, a few writers seem to be good, and a few others, those writers may not seem to be good. So it depends from person to person. So it is opinion based. Set is not opinion based. Set is if I list down the elements of a set, if you list down the elements of a set, the elements must remain the same. For example, let's say the set of all Kannada writers. If I say this, then you can list down the writers who write in Kannada, right? If I say the set of all Indian cricket players, then you can list down the cricket players who play for India. If I just say the set of all good cricket players, then you may not be able to list it down, because for me, if I say some cricket player is good, but you may not find him or her to be a good cricket player, right? So if I am giving a definition for the collection, I should be able to list down the particular elements. Then only I can say that that collection is a set. Okay. If I have to give another example, the collection of all intelligent students. It is not again well defined. For me as a teacher, a few students might seem intelligent, and for other teachers or for someone else, that those particular students may not seem to be intelligent, right? Of course. But if I say the set of all students in a class who have scored, let's say, above 95 percentage in the previous year, then of course every teacher is going to, or every person who is looking at their scores, are going to list down those specific students who have scored above 95, right? So the students are remaining the same. If I say intelligent, then for me and for the other person it is going to be different. But if I say above 95 percentage, then it is going to be same for me, and it is going to be same for the other person as well. So such a collection is called as a set. Okay. If you rightly remember, there were two ways to represent a set. There were two ways to represent a set. The first way was the roster method, and the second method was the set builder method. The set builder method. The roster method was also called as the listing method, or the set builder method was also called as the rule method. What do you mean by these, if you rightly remember? In the roster method, what we used to do was we used to list down the elements separated by commas and enclose them in the braces or the flower brackets. For example, uh, let us say there is a set A which is equal to 1, 2, 3. So it is the set of all the elements 1, 2, and 3. Okay, so these are called as the elements 1, 2, and 3, which are separated by commas, and we have enclosed those in the flower brackets. Now, how do I represent this using the set builder method or the rule method? As the very name says, it is the rule method. So I'm going to define a rule, or as it says, it is the set builder method. So by the rule that I give, we can define or we can build the set. Okay, we are not going to actually list down the elements of the set, but the rule and what I am writing will be able to build the set. For example, let's say a is equal to, if I have to write this set as, I mean, in the set builder form or in the rule form, what I can say is the set of, I will take up one representative element, let us say x, the set of all such x which will satisfy a rule. What is the rule? Such that x is what, I have 1, 2 and 3 which are natural numbers. Of course, x is a natural number, x is a natural number. Okay, and see, if I say x is natural number, I will just get 1, 2, 3, 4, 5 and so on. I mean, up to infinity I can just keep on writing, but I have to stop at 3. So I have to say x is less than or equal to 3. So this is where my rule ends. So now basically what this set is going to do, it is going to list down all those natural numbers which are less than or equal to 3. What are the natural numbers? The natural numbers will start from 1, the counting number. So 1, 2, 3. But I cannot go to 4 because the set is restricting that I have to stop at 3. So it is going to be x is less than or equal to 3. And I can also say x is less than 4 because less than, when I say less than, I'm not going to include 4, I am going to stop at 3. So that flexibility we can afford. Okay, once we have this, this is going to list down all those uh, values of x which are going to satisfy this particular rule. Fine. So now, instead of writing x is a natural number, we had, if you remember, we had given a few standard sets to you in the first PUC. What are those standard sets? The set of all real numbers R. In the textbook, they have denoted it by R, but once we start with the chapter relations and functions, we denote even the relation by the letter R. So it is obvious that we will sometimes get confused which is the relation and which is the set of all real numbers. So what I shall do in my lectures is I'll take up the set of all real numbers as slash r, the set of all natural numbers as slash n, the set of all rational numbers as slash q, and the set of all integers as slash z. Okay, of course, the set of all positive real numbers as r plus and so on, the z plus q plus. Okay, n of course is always plus, so there is no issue with it. Now, how can I write down the set A again in the simpler form? The set of all x such that x is a natural number, so x belongs to the set n. I can say this, right? X belongs to the set n means what? X belongs to the set of all natural numbers means x is of course a natural number and x is less than or equal to 3. So this is also one of the ways in which I can represent a set. Okay, so this was all about the representation of the sets, and the sets are usually represented by capital letters. That is obvious. Okay, now once we had all this representation and all that, and then we had the types of sets. If you remember the types of sets, in the types in the first beginning we had the empty set. What is an empty set? Empty set is the set which has no elements. Of course it is empty. We denoted it by the empty braces or the Greek letter phi. Okay, so this is what is the empty set. And we had also said the singleton set. What is the singleton set? Singleton set, I think this is not given in NCERT. The singleton set is the set which has only one element. Okay, and then we had finite and infinite sets. If you remember, finite and infinite sets. What is a finite set? Finite set is a set which has finite number of elements, and infinite set is a set which has infinitely many elements. And uh, please don't use the terms such as countable number of elements or countable set and uncountable set. Mm, See, if you go for the higher mathematics, then you will understand that a finite set and a countable set both are not same. Okay, so countable set is totally different. A few students do write in the examination saying that countable set is said to be a finite set. No. Okay, so don't use the terminologies that you have not learned. Okay, you can just say the set which has finite number of elements is a finite set, and the set which has infinitely many elements is called as an infinite set. Okay, so if I have to give an example for a finite set, it can be, let's say, the set A here, whatever I have, it has three elements, right? So I can set the set A. Or if I have to define, let's say, another set B, 1 2 3, let's say, so on up to, I have to terminate. If I just write three dots and leave it, then just continues, and it is going to have infinitely many number of elements, right? So what I'll do is I will stop at some point, let's say 35,000. I'll not put comma here. 35,000. So at 35,000 it is going to stop. It has how many number of elements? 35,000 number of elements, and it is of course a large number, but it is not infinity, so it is not an infinite set. But if I just write down, let's say, a set C as 1 2 3 and so on, then it has no termination, it can just keep on going, so therefore it is going to be an infinite set. Okay, now once you define finite set and infinite set, we have something called an equal sets. I mean, equal, not an equal set, it is equal sets. What do you mean by equal sets? Two sets are said to be equal only when the elements of the two sets are one and the same. For example, let us say if I say the set A is equal to 1 and 2. Okay, so let us say this is the set A that I have, and I have another set B which is equal to, let's say, the set of all x such that x minus 1 into x minus 2 is equal to 0. This is the rule method, right? So if you build this set, what is it going to be? The set B is going to be x, see, either x minus 1 is 0 or x minus 2 is 0. So x minus 1 equal to 0 means x equal to 1, x minus 2 0 means x equal to 2. So the set of all x which will satisfy this rule is going to be x equal to 1 and x equal to 2. So here you can see A and B have the same elements, that is 1 and 2. So therefore here I can say is equal to B. Okay, so when can I say that two sets are equal? I can say that two sets A and B are equal only when the set A and B have the same elements, right? So this is what is about the equal sets. And then if I have to go with the next topic, that is the subsets. Okay, so what is a subset? What is a subset? Let's say that I have two sets A and B. Okay, if all the elements of A are in B, then we say that A is a subset of B. Then we say that A is a subset of B. So let us say A has, let's say A is equal to 1 2 3, and then the set B is equal to 1 2 3 4 5, and then let's say the set C is equal to 2 4, let's say, that's all, 2 4. If I want, I can include 3. Okay, you can see 1 is in B, 2 is in B, 3 is also in B. So all the elements of A are in B, so I can say that A is a subset of B. If I say A is a subset of B, then I denote it as this, denoted by this symbol, that is A is a subset of B. Okay, this is how I write it. You can see the elements of C. 2 is in B, 4 is also in B, and then 3 is also in B. So therefore C is also a subset of B. Okay, so C is a subset of B, A is also a subset of B. In this case, okay, if A is a subset of B, okay, if A is a subset of B, then B is called as a superset of A. Then B is called as a superset of A. This is one terminology that sometimes they might use in few questions. Okay, so if A is a subset of B, then we say that B is a superset of A. And also, in this case, I will define the one more term here. As you can see, we have three sets, A, B, and then C. Among these three sets, A is also a subset of B, C is also a subset of B. So we had three sets, out of which B is the superset of both A and C, right? So what I mean to say here is we had some number of sets, out of which there is one set which is the largest, and all the other sets are the subsets of that. So such a set is called as the universal set. Such a set is called as what? It is called as the universal set. If I have to give you one more example, let us say set x equal to uh, a, E, I, O, U, that is the set of all vowels in the English alphabet. The set Y equal to B, C, D, F, so on up to Z, the set of all consonants. And then if I take, let's say, the set Z equal to A, B, C, D, E, okay, and then let's say the set U equal, no, I will not take U, let's say M equal to uh, x y z, okay, and let's say the set uh, p equal to a b c d, so on up to z, the set of all alphabets. You can see I have 1, 2, 3, 4 and 5 sets. Okay, out of these 5 sets you can see X is a subset of P, Y is also a subset of P, Z is also a subset of P, and M is also a subset of P. So, X, Y, Z, M, all these are subsets of P. So, I have 5 sets, out of which there is one large set P, which is a superset of all the other sets. So, such a set is called as the universal set. It is called as what? It is called as the universal set. Okay. So this is one thing that I had to say in the case of subsets. Now, coming to the number of subsets, the number of subsets. Okay, how to form a subset? That to that point I'll come a bit later, but I will just let you know the number of subsets of a given set. If let us say if A has n elements, if A has n elements, we also denote it as n of A. Okay, if n of A is equal to n, that is the number of elements in the set A is equal to n. Okay, if A has n elements, then the number of subsets of A is going to be 2 raised to n. Then the number of subsets of A is going to be what? 2 raised to n. We can calculate this using the fundamental principle of counting. Probably, if possible, we will do that while revising the chapter permutations and combinations, because for that you would need the revision of the fundamental principle of counting. Okay, so we shall take that up possibly in the upcoming chapters. Okay, we will leave that as of now. The number of subsets of a set which has n elements is going to be 2 raised to n. Okay, for every set A, if I have, okay, uh, let's say if I take up a set, the set 1, 2, 3. Okay, for this set, I will always have two subsets. Let's say the first subset is going to be the null set. Why is it a subset? Because see, null set has no elements. Of course, no element in the sense I can obviously say that all the elements of this are in the set A, because there are no elements in the null set, right? So null set is going to be a subset of A. And I can also say that this set itself, that is the set 1, 2, 3, is also a subset of this, because all the elements of this are in A. So for every non-empty subset A, I mean for every non-empty set A, there will be two different, I mean two subsets for sure. The first one is the null set and the second one is A itself. So these two subsets are called as the trivial subsets. These two subsets are called as what? These two subsets are called the trivial subsets. Now, out of these two trivial subsets, the set A itself, I mean, for every set A is going to be a subset for sure. That set A itself is called as, it is called as the improper subset. It is called as what? It is called as the improper subset. So therefore, for any given set A, for a set A with n elements, with n elements, okay, what we can say is the number of subsets, the number of subsets are going to be 2 raised to n. Okay, the number of trivial subsets, trivial subsets is going to be 2. Which are the trivial subsets? It is the null set and that set itself. So those two sets are called as the trivial subsets. The number of improper subsets is going to be just 1. For every set A is called as the improper subset. And out of these 2 raised to n, 1 is improper. So the remaining would be proper subsets. So the number of proper subsets is going to be 2 raised to n minus 1. So these are the total number of proper subsets that we have. Okay. So this is all about the number of subsets of a set. Now coming to the subsets of the real numbers, the subsets of the set of all real numbers, that is R. Okay, uh, we all know that all the natural numbers are real numbers, all the rational numbers are real numbers, all the irrational numbers we denote it as Q dash. We'll just discuss what is the meaning of Q dash a bit later. So all the irrational numbers are real numbers, all the integers are real numbers, right? So all these are going to be the subsets of real numbers, of course. So for all these sets, I can also say that the set of all real numbers is the universal set, right? So by our previous discussions, I can make the statement. Nevertheless, this may not be very useful, but the useful fact is that if we need, let us say, we have, let me consider a real line. Okay, what is a real line? This real line will consist of all the real numbers, okay, from negative infinity to positive infinity, all the real numbers on this. Let us say there are two real numbers a and b on the real line. Okay, if I need all the elements between a and b, I introduce a concept called the intervals. I introduce a concept called interval. What are the intervals? Intervals will give you the set of all the real numbers between two fixed real numbers. Okay, with some conditions. What are those conditions? See, there are basically four types of intervals. The first one is the closed interval. The second one is the open interval. The third one is semi-closed, semi-open interval, and the fourth one is semi-open and semi-closed interval. What are the meaning? I mean, what is the meaning of all these types of intervals? Let's see. Uh, See, whenever we write down the closed interval AB, this means it is going to give you all the real numbers between A and B. Of course, that is the duty of the interval. It should give you all the real numbers between A and B, including A and B. When I say it is closed, that means it is going to include both A and B. Whenever I say closed, it is the meaning of that is include. Okay, you can remember it this way. And whenever I say open, the meaning of that is exclude. So it is going to give you all the real numbers between A and B, including A and including B. It will include both A and B. But when I say the open interval AB, it is going to give you all the real numbers between A and B, no doubt. Okay, all the real numbers between A and B, definitely, but it will exclude A and it will exclude B. So that's why I have created a hole there. A is not included, B is also not included. But when I say the semi-closed, semi-open interval, it is of course again giving you all the real numbers between A and B, but it will include A and it will exclude B. Okay, same is the case with the next one, the set of all real numbers between A and B, excluding A, including B. So this is what we have. Okay. So this is all about the interval. So since all the numbers that are lying in the interval are going to be the real numbers. So all the intervals that we have listed out are the subsets of the set of real numbers. Okay. So this is also what we had learned in the chapter sets. And after all this, we had a small section in the chapter which was the operations on sets. Operations on sets, right? So what are the operations on sets that we have? There were the first operation that we had learned was the union of two sets. What is the union of two sets? It was also denoted by cup like this. Okay, what do you mean by the union of two sets? It is the set of all elements of the set A or B for any two sets A and B. Okay, so if I write, let's say A is equal to the set of 1, 2, 3, and B is equal to the set of 2, 3, 4, then what is A union B? A union B is also denoted by A or B. What do you mean by A or B? It is the set of all elements which are either in A or in B or in both. Okay, so there is no condition that the element has to be both in A and B. No, the element has to be either in A or in B or in both. Okay, so there is no restriction at all. Now, what is going to be A or B here? 1 is in A, yes, not in B, we are fine with it. 2 is in A, yes, 2 is also in B, we are fine with it. 3 is in A, yes, 3 is also in B, we are fine with it. 4 is in A, no, but 4 is in B, we are fine with it. So there is no restriction at all. It can either be in A, or it can be in B, or it can be in both. So that is going to be the union. The second one is going to be the intersection of two sets. The intersection of two sets. Intersection is usually denoted by a cap like this, and we write it as A and B. What do you mean by A and B? The set of all elements which are both in A and B. So as it says, the word itself means the intersection. What do you mean by the intersection? Intersection means uh, the common point. What do you mean by the common point? The common elements in this case. So if I take A intersection B, this is going to be the common elements of A and B. 1 is in A but not in B. 2 and 3 are in both A and B, so it is going to be 2 comma 3. Okay, so there are a few properties of union and intersection which are not very important at this point, but if we come across, I mean, if we have to use them in any of the problems that we solve, then we shall take those up. Okay. The third property that we had learned was I think the difference of two sets. What do you mean by the difference of two sets? It is the set subtraction. You can also call it as a set subtraction. Uh, it is denoted by A minus B or B minus A, not or B minus A and B minus A. I'll tell you why. What is A minus B? It is the set of all elements in A which are not in B. What do you mean by the set of all elements in A which are not in B? See, 1 is in A but not in B, so I can include 1. 2 is in A but 2 is also in B. Since I am subtracting B, I am not going to include 2. 2 is not included. 3 is in A but 3 is also in B, so therefore I am not going to include 3. So A minus B is going to be singleton one. Now, what is B minus A? B minus A is going to be the set of all elements in B which are not in A. 2 is in B, but 2 is also in A. I am not going to include. 3 is in B, but 3 is also in A. I am not going to. But 4 is only in B, so therefore I am going to include 4. If you observe, I just said 4 is only in B, and I said 1 is only in A. So therefore A minus B is sometimes also called as only A. Why is it only A? Because it includes the set of all elements which are only in A but not in B. Right? Similarly, B minus A is called as only B. Okay, so this is what we have. And after this, there is one more operation that we have, which is the complement of a set. Complement of a set is very easy. What do you mean by the complement of a set? For any set A, the complement is denoted by A bar or A dash. Okay, so what is the meaning of A dash? That is the complement of a set. It is going to be U minus A. For any set A, the complement of a set is U minus A. What is U minus A? U minus A is called as the complement, and what is U? U is the universal set. U is the universal set. Okay, so this is all about what we had learned in the uh, chapter sets. I think now it is the time that you take a pause and you revise whatever you have learned, and if possible, you make a few points. in the NCERT, they have given a note after the chapter sets. Go through it. If possible, you may list down the points. And there are a few MCQs in the chapter as well. Try to solve those MCQs and solve a few exercise questions. And then we shall meet in the next lecture with a few problems on sets. Uh, we will, if possible, take up a few previous year questions and a few more important questions in the next lecture. Okay.